serverless to Elixir. I recently rewrote a service that was on AWS API Gateway and Lambda in Elixir, and apparently that intrigued some people. So I decided to do a small write-up. You know why? You know why? You want to guess why? It's because it involves Elixir, okay? It has nothing else to do with serverless or anything. People just want that Elixir juice in their life at all times, every time, always. This post is going to be about our motivations for the move and what replacement implementation looks like. This post is not a critique of Node.js, Lambda, or serverless movement, but a word of caution about how pricey it can become if your services end up going web scale. Mongo database trademarked. We started with the original service was designed to collect an event stream from various web browsers, collecting different client metrics and ingest them into a greater ETL. Extract, transform, load. I love a good extract, transform, load system. We had previously been using a third-party logging solution that was getting expensive, and we did not provide ways to extend or interact with the data we stored in a way we needed to. Here's a very generalized diagram of our original system. All right. A Kinesis stream. Okay, I like that word. You know, it reminds me of Kinesis, the keyboard I use. Hashtag ad. Ah! Use code Primogen for 15% off. Actually, it's Prime 360 if we're going to be real. It's Prime. It's not even Primogen. It's actually Prime 360. That was a great ad, by the way. Didn't even plan the ad, but it totally works. Links in the description. All right, anyways, so they have API Gateway, Kinesis Stream, JSON Schema Validation Lambda, all sorts of crazy magic. Okay, this looks like every single project. Dude, basic AF. Okay, I love this article. This article is so good. API Gateway. We bound our API client endpoint directly to a Kinesis stream using velocity templates so that the downstream Lambda function could take the advantage of Lambda Kinesis functionality and concurrently be invoked to process batches of HTTP posts. We knew that this service would be handling lots of HTTP requests at a time and did not want to run into throttling issues with Lambda. So processing it off a queue in batches was a solid choice. Okay. I mean, batching is always a good plan. Kinesis. Our Kinesis stream has varied in size a bit, but if I recall correctly, its highest throughput was 60 to 80 shards to avoid getting write provisioned throughput exceeded. That's a lot of shards. Our Lambda was in charge of pulling batches off the queue, validating that the data made sense, collecting metrics on our metrics, classic yo dog, you like metrics, and ship off the results to a whole other land of magic to dispatch notifications, store replicas of data in S3 for posterity and compliance, manage log/event retention, and ingest events into gigantic Elasticsearch 3 cluster. All right, to summarize, each post adds an event to the Kinesis stream. A Lambda pulls off about n events at a time for processing. Everything is hunky-dory for now. This is actually a great introduction. They gave us the meat, they gave it to us raw, and we got none of the annoying parts. All right, the system worked fantastically for well over a year. It scaled very easily, required almost zero attention. This is good. I mean, this is a good argument for why relying on other people's infrastructure is such a great argument. It's because you don't have to do shit to it. When you build it, it just works. It's fantastic. Absolutely in there. More teams and projects in the company began to interface with it. And then, beautiful. Daddy Bezos coming in hot. Let's go. Then it got expensive. Why we needed a change. API Gateway alone costs about $3.5 per million HTTP requests. That's awesome. I can run my side projects on it for free. I can build stuff in it rather quickly and get things done. But when it scales, so does the bill. Our service didn't quite grow exponentially in use, but it did hockey stick. It went from free to a few $100s to around $12,000 just for API Gateway. No Kinesis, no Lambda, just API Gateway. We are doing about 5 million requests per hour. You're telling me it only costs $350 per million? It's be about $350. I can't believe I did not recognize $350. Like, it was right there. $350 was right there, and you're telling me I didn't even see it? 12,600. That's a lot of $350s. Yeah, again, there is no Lambdas doing business logic yet. That's just cash to get the events in. That spend is sustainable, but obviously a waste, and we knew that we were going to be adding additional load to the system in the near future. Currently, we are processing up to 12 million events per hour. Let's do a math if we stayed on API Gateway and Lambda. All right, we're up to 30,000. 30,000. Glad we dodged that one. There's 30 days in a month. Classic 30 days in a month. Bleeding, let's see, from bleeding cash to let it crash. That's an Erlang joke. Okay, I don't get it. So a lot of people ask me, why not Go? This is a great question. Dude, I love this question. I've only written a few CLI 2Es and created a few PRs in Go. I am not, nor do I pretend to be a Go guru. We had a system running at a high scale, and I couldn't risk building it in something I didn't know how to write efficiently and operate. That's one of the beauties about Go. You pretty much always write it pretty efficiently. Aside, I did build the prototype in Rust for fun one weekend, but it felt irresponsible to deploy it with given I had absolutely zero Rust experience. Dude, this is such a great take. You know, we all love these bespoke artisanal languages, but man, is that hilarious. Why not Node? It was already written in Node. Actually, most of the code-consuming parts were written in Terraform to deploy it all, and velocity templates to do some in-flight request manipulation to ingest into Kinesis. The Node Lambda was rather simple. It pulled off batches, validated them, and sent them on their way down to the second Kinesis stream. If I was going to set up my own Express server or whatever, and then it would only be replacing API gateway portion, and my goal was to replace the gateway and the Lambda in one operation. Get the preliminary Kinesis stream out of there. This Lambda was originally processing batches and shipping off batches. Now the function handling individual requests would also need to handle the batching. We did not want to hit Kinesis with a single record at a time. Okay, I don't know what Kinesis is. What is Kinesis? I've heard the word Kinesis like 18 times. I don't really work with Amazon. What is the Kinesis? What is it? What's the thing? What does it do? Someone tell me. It's an AWS Kafka or Kafka alternative? Oh, okay. Oh, okay. The keyboard maker. The Amazon Q. Okay, is that the SNS, SQS stuff? Is that like the proper name behind it? Yeah? No? Okay, that's different. I've only used SQS and SNS, right? Stuff, and only very little of it. SQS is a separate product. Okay. It's a big data streams. Oh, okay. Yeah, I've never really, I mean, I played with Kafka at Netflix. I've never played with it anywhere else. We have our own internal Kafka stuff. And Mantis. And Raven. Raven on top of Mantis on top of Kafka. There's a lot of abstractions there, okay? It's a lot. There's a lot of things. Anyways, to get the preliminary, we already talked about this. So if I built it in Node, I would either have to hack up some global variable to save my state or depend on some external data store like Redis to memcache. Why not COBOL? No one asked me that. It's a valuable question to be asked. But why Elixir? This system has to be up when the rest of the world falls apart. This tool is used for debugging issues in client software that runs on a lot of high-traffic websites. It also has to be absolutely fast. Our client library is for sending lots of information per page load in a lot of customers' apps. We can't go slowing down our customers' user experience. At the same time, we decided since we are running our own HTTP interface, now that we should give feedback 400 bad requests if the data is invalid to the developer per request instead of making them look at what the reporting tool down the line. Keep the user's experience good. Make the developer's experience better. Okay, it's cool, and I enjoy writing and reading it. Honestly, one of the most valid reasons. Again, this is the truest form of DX. I can take advantage of language features to reduce the need for external dependencies like Redis or Memcache. Okay, that's cool too. Actually letting it crash. Like all software projects, I shipped this to production. I forgot everything right from the first time. Or, hold on. Like all software projects, I shipped this to production and got everything right the first time, and it worked fantastically. Everyone patted me on the back and said, good job. We shared egregious high fives, and people actually carried me out of the office on a chair over their heads. Yep. JK, I screwed this bad boy up a few times and pretty sure I set a server on fire somewhere in the AWS region. My first attempt. Handling the HTTP request is the easy part, but I had to batch up data to ship off to Kinesis. One way to use AWS Kinesis HTTP API, but they also have a Kinesis agent that I've run on plenty of servers. So I figured I would use Elixir built-in logger module and run a sidecar container with Kinesis agent configured to ship my logs. Dead simple. Nice. Well, that blew. Let's see. Well, that blew to bits quickly. The Elixir standard logger mentions alternatives between sync and async modes to remain performant when required, but also applies back pressure when under stress. There's no way I'm going to do that. That pretty much sounds like everything I've ever done in my lifetime. Literally. Every single time I think that's not going to happen, that happens. I don't recall the exceptions offhand because this was the quickest I've ever shut down a multivariate test or rolled back code, but I drove the logger straight into the ground. Request times skyrocketed, memory went off the rails, and I started seeing all sorts of errors or all sorts of crashes in the logger process. Steam started coming out of everything, and I swear I saw a sprocket fly off. I kind of backed away slowly from that approach. My second attempt. I wanted to make sure I circumvented any back pressure. I needed to keep the request super fast, so I replaced the logger module with a simple write to a file that Kinesis agent would read from. Writing files in Elixir also happens through a process, but you can open up a raw access to a file. Okay, I like it. Here's a little bit of code, style forage. Storage file, a little file storage, a behavior event stream storage, new line. Okay, I don't know what any of this means because this isn't that fake-ass language Elixir, what am I looking at? I don't even know what I'm looking at. What is this? What is that? I don't know what that is. Seems fake. Write, file, log file, message, whatever that means. Raw dog me and append it. Okay, they are attribute. Yeah, sure they are. Okay, sure they are, Elixir champion. Sure they are. I'm using a behavior, an interface in other languages for storing data. This allows me to have a nice, easily inspectable implementation of the store in my test suite. Oh, that's nice. Yeah, good job. Traits are great. This actually worked amazing. Request times dropped so low, I thought it wasn't working. Then, RAM went crazy. Things are obviously askew when a web server is using 10 gigabytes of RAM. This wasn't Elixir's fault. It wasn't Kinesis' fault either. Anyone know what it was? I mentioned a sidecar container above. This is running in Kubernetes, and 3 containers, Elixir, Kinesis, log, rotate, are sharing a volume. That volume behind the scenes is running with tempfs, which is an in-memory file system. I could change it to disk-based, but then I realized my goal was to lower dependencies, and now I was sitting on a container full of them. Was log rotate deleting files before Kinesis agent parsed them? I don't know. I hope not. I know this is getting real. This explanation is thorough. Oh my goodness. This is why I don't see for the near future DevOps being anything but a growing career path. Is because there's so much required in all of this. You know what I mean? Like the amount of stuff required to know, understand, and be fast at is insane. I think DevOps is the only thing that rivals like the front-end ecosystem for just the amount of insanity that there is. Like the amount of things you have to come up with and do is really fun. But I will say that in like the DevOps-y back-end stuff, it's so much more fun. You know, you're building these tests, you're trying to run, you're splitting traffic, saying does it live? Do you do shadow traffic? Do you like inspect? Like it just feels, for me, it just feels more fun. But some people really do love the front end. I don't know. It's not for me. It just feels more fun, right? All those dollar-sucking Bezos from Mr. Bezos made me forget that time-honored software principle. Keep it simple, or keep it simple, me. The solution was a few gen servers. For people not from the Erlang or Elixir world, gen servers are a tool for implementing a client-server relationship that allows for storing state and processing work asynchronously with a simple API. It's built into the language, and a fair amount of language features are built on top of it. Here's an oversimplified diagram of my supervision tree. Application, it's very bright. Event stream queue, event stream server, event stream worker. Okay. Server supports async and sync calls from HTTP request to place an event. Async responds fast with the 201. Sync responds with any validation error. This allows developers working on the integration to ask for errors when they are debugging, but run efficiently when they are releasing code to clients. Queue holds batches of work. Kinesis supports up to 500 items at a time, up to 5 megabytes in size. This queue gets pummeled by requests, and internally it stores a set of batches. When the count or size is exceeded, it asynchronously sends a batch to the worker. This gen server traps exits. Oh my goodness. This gen server traps exits. Wow, too many S's. I can never read too many S's in a row. This gen server traps exits and also dispatches events to the workers when it receives an exit. Worker makes a call to Kinesis, put record via a library called XAWS. If any event failed to write, they are placed back into the queue to be reprocessed. I mean, it sounds simple. It sounds simple on paper. How emotionally damaging was it, though? Can we all at least come to recognize that the amount of emotional damage that went on in this probably was a bit higher than we would like to admit. With this approach, I have one binary to ship to no external dependencies. Okay, that's good. That's actually really awesome. This has been working fantastic. Response times are sub-second, and resource utilization is almost constant. Here's a graph of CPU versus RAM during our high traffic time. Well done. This is great. Very consistent. Love it. Love to see it. And our numbers. Well, rock on. Rock on. The CPU usage per Elixir node ranges between 0.6 to 1.8 under heavy load. RAM stays pretty consistent in the 100 to 150 range, although I currently over-provision it just in case. How does this compare cost-wise? It's a lot cheaper for us. Mind that we already have an ops team, and we already have a Kubernetes cluster running. Our additional costs are the fractions of EC2 instances that Elixir nodes are consuming. I could argue that it's free since they are running on leftover compute, but for comparison with numbers above, I'll calculate the cost. I'll use CPU since that is what this service is mostly constrained by. Yeah, that makes sense. Our general Kubernetes instance group is running on T2.2XLs. That is 44 cents per hour and have 8 virtual CPUs each. So that makes about 5 cents, 5 cents per CPU per hour. Okay. We're currently running 3 to 5 Elixir nodes using between 0.5 to 2 CPUs each. On the lower end, $59. On the higher end, $397. They went from what would be $30-some thousand now to $500-some on the high end. Well, remember, it's not 12K. 12K was the old numbers. It went up to 30K with where they're at now. And that's just for API Gateway. Remember, they replaced API Gateway plus the Lambda service. So, that assuming the Lambda service isn't zero, it's something, right? Let's just assume it's not zero. We haven't had an Elixir node using above 1.8 CPUs, and on average, we're running 4 nodes at a total of 1.1 CPUs. Okay, so $174. So should everyone go and rewrite their serverless servers in Elixir? Roll out Kubernetes? Get a nose piercing? Absolutely not. Get a nose. A good part of this entire system still runs on in Lambda, although it will be moving into Elixir over time to make it easier to reason about and develop on locally. What everybody should do is think about where your service is going and can you afford those costs when you get there. If you don't have a team of ops people and you aren't familiar with serverful stuff, spending $30K a month on HTTP requests might be cheaper than an ops team. Absolutely. This is a great call out. You got to decide what sword you're going to fall on. But if you're already at 30,000 and you're planning on doubling or tripling, you got to start thinking about the future, right? At what point do you change course, and when do you know to change course, right? It's really about trying to predict the future. But if you have the team, you know how or will. Once you hit the scale, there is a lot of room for savings by running your own infrastructure. Update. I was asked on the Elixir forum about the loss tolerance. I'll go into that a bit more in detail here. Footnotes. A downside. Oh, it'll go into here. It's some other article. If you follow the link, you can find the link. Footnotes. A downside to this approach was developers using this async service. We returned 201s and were unable to tell them at the time if the data they sent was valid and ingestible. Yeah, I was wondering about that because they do a 201 first and then they do like another reporting. They would have to use some additional tooling to see if their events made it to where they were supposed to go. Okay. The system uses itself to monitor different aspects of itself, like ratios of malformed events, throughput, and workflow step counters. Okay, interesting. It's the compiler that builds itself. The back half of the system is still in Lambda and Node.js, but the invocations are tiny in comparison to what was being invoked by the Lambdas exposed to the user interactions. Yeah, because the batching happened here, so it's 1/50th, right? So that means 12 million becomes what? Hundreds of thousands? 2,000 events was our sweet spot for real-time rendering of graphs. Oh, okay. You may be thinking that sounds like that can be replaced with the Kinesis Firehose transform function. It could be. I wasn't aware of or it didn't exist at the time our system was originally designed, and now that we need to get off the API gateway, it doesn't matter. It is a rad feature, though. My wordplay is out of this world. I actually agree with this entire thing, including point 6. I actually was thinking this entire time, this guy is an inspiration as to how to make jokes for technical content. This is such a good article. This is such a good article. Hypermedia, please. This is a good article. Okay. Hold on. There you go. The article, that's a really good article. The article is really, really good. I just love this stuff because, I'm a bit of a contrarian, sometimes for the sake of being a contrarian. And I know that's not good to be a contrarian for the sake of contrarian. But when everybody tells me how amazing serverless is and that there's no downsides ever and everything's great and everything's fantastic, there's some part of it that feels... It feels like I'm being lied to. And I feel like I have to simply go against the grain completely just because I don't believe people. You know what I mean? Like, how many times have you been in a meeting and someone states like, this thing does this. And you're like, no, it doesn't. It does not. Whatever you're like, oh, dude, we've had people be like, oh, JSON's cheap. And you're like, no, it's not. JSON is like half of what your server does. It's not. It's amazing for Node, which is harder to have long-running services. Yeah, it's very funny you say those kind of things because what that says to me is that Node is fundamentally sucky. If it's hard to have a long-running service, it's not Node's fault. It's JavaScript. JavaScript, it's just so easy to make mistakes. It's so easy to do the wrong thing in. I'm not convinced it is fantastic. I just simply am not. I'm convinced. I don't like that statement. You should be able to write a program that lives for a long time. I don't know. It's just strange to me. Anyways, I'm just very, I will always be very, very contrarian, even potentially contrarian to a fault, just because I want to go against the grain. I don't believe when people say things are fantastic because I've never seen something be fantastic. So this article is awesome. It just shows that there is more nuance to that conversation. It's not as cheap or as free as people make it. But if you don't have the team or the experience, sometimes it's worth having a fake engineer who's worth $400,000 a year on your team because it takes care of everything for you. You know what I mean? The name is the Primogen.